You are asked to determine the atmospheric pressure using a dry air column kept in a coil tube of length L. The figure shown is complete and not drawn to scale. Part A. Complete the experimental setup by drawing appropriate items and name them. Coil tube means a small tube, and there is a one closed end. This end is closed, this end is open. We have to tap an air column in this place by using mercury column. They have marked mercury column as X, air column as simple L. Total length of the coil tube is name of the tube. We have to consider the tube as coil tube. This height is H. Now, when completing the experimental setup, we have to draw a meter ruler. We have to connect coil tube. It is approximately 1 meter. Coil tube for the meter ruler by using rubber band. Then we have to name it meter ruler. It is the basic requirement, but we can draw a stand to complete the experimental setup. Then part B, what is the approximate value of the length and internal diameter of the coil tube using in this experiment? Length of coil tube approximately 100 centimeters. We can get it 80 to 100, about 80 to 100 centimeters. Or you can write it 100 centimeters. Internal diameter 2 or 3 millimeters. I will write 3 millimeters. 2 millimeters or 3 millimeters. You have to remember that you should do the experiment to get the correct approximate diameter, or you can remember it. It should be 2 millimeters to 3 millimeters, 2 or 3 millimeters, about 2 or 3 millimeters. Then part C, what should be the approximate length of mercury column used in experiment and write the correct answer. When using mercury column, we have to remember that we are using meter ruler to measure the mercury column. Therefore, the measuring length should be equal or greater than 10 centimeters. We know that when using meter ruler as the measuring instrument, to percentage error less than 1, the minimum reading should be 10 centimeters. Therefore, we have to reject 2 centimeter answer. You can write 10 or 30 centimeters, but best value is 10 centimeters. If we are using 30 centimeters, the length of air column is a small value. Therefore, the best length for the part C is 10 centimeters. For this one, we have to write just only answer, but you have to remember we are getting 10 centimeters due to 2 reasons. First one is for the meter ruler, for the measuring instrument, percentage error should be less than or equal 1%. Therefore, this is the minimum reading we can get meter ruler by considering a negligible percentage error. And second reason is, if we are using 30 centimeters, it is a greater value. When using 30 centimeters mercury column, the pressure of air column is increasing. When the pressure of air column is increasing, its volume is decreasing. Therefore, we can't get a measurable length for the air column by using meter rule. Length of air column also should be greater than 10 centimeters, because of we are using meter ruler to measure corresponding air column. Then part D, the internal cross-sectional area of the tube is A and atmospheric pressure is H in mercury centimeters. Here L and H values are in centimeters and A is in square centimeters. Write down an expression for the pressure of the trapped air column in capital H, simple H, X and L. We can write pressure, D part 1. Pressure, when getting pressure, we know that pressure at this place is atmospheric pressure. They have given that atmospheric pressure is capital H. Plus, we have to add pressure due to this mercury column. When getting pressure due to mercury column, we have to consider this height, because of we know that when considering the pressure due to a liquid or fluid, we have to consider the vertical height for H rho G. Then I will consider this angle theta. Then we know that this angle also theta. We can write sin theta is this height divided by length of mercury column. Then we can subject this height X sin theta. Again I will write it. I will consider this height as y. It is the vertical height. Then we can write sin theta opposite divided by hypotenuse by using this small triangle. Then we can subject y value is x sin theta. It is in mercury centimeters, and this value also mercury centimeters, because of we are using mercury state. We are using a mercury state, and we are using height of mercury state. Therefore, these two values are in mercury centimeters. Therefore, we can use without any unit conversion. Now, we have to substitute sin theta value. We can write sin theta by using this large triangle. We know that this angle equals this one, corresponding angle, and when considering large triangle, opposite relative to this angle is simple H, and hypotenuse is capital H. Then we can write simple H divided by capital H. It is the pressure of the gas. Then part 2, applying the Boyle's law to the trapped air column, write down an expression to determine H in terms of H, X, capital L, simple L, capital A, and constant simple K. We know that according to Boyle's law, PV product is constant for a gas if the temperature is constant. Now temperature is constant, therefore we can use PV is constant. Then we can substitute pressure H plus XH over capital L, it is pressure. We have to multiply by the air volume. Air volume is cross-sectional area into length. It is a cylinder, therefore cross-sectional area into length. We have to write just the relation. We have to just write the relationship. Therefore, we can get it as the answer. It is D part 2. Then part 3, rearrange the expression obtained in D2 above to determine H by plotting a straight line graph. When plotting a straight line graph, we can change simple H. Simple H is the independent variable. We have to change simple H. We can change simple H from minus capital A to first capital A. If this one is the tube, if it is in this position, its value is minus L. If the tube is in this position, its value 0. If the tube is in this position, its value plus L, plus capital L. Therefore, simple H is the independent variable. And simple L, length of air column, we are measuring it. It is the dependent variable. We have to subject the dependent variable. When subjecting the dependent variable, I will bring L value to the right hand side. Part 3. H plus H over capital L into A. Now I will bring A and L value to the right hand side. Then K divided by A. Now we can subject 1 over L. To subject 1 over L, we have to multiply equation by A and divide by K. Then we can get H A over K plus H over L multiplied by A divided by K equals 1 over L multiplied by A divided by K. Then we can cancel out A and A, K and K. Then we can subject 1 over L equals H is the independent variable, X A over Lk times H plus HA over K. Now it is in the form Y equals mx plus C. Then part 4. In the graph mentioned in D1, D2, D3 above, identify the dependent and independent variables. Part 4. Independent variable. It means the physical quantity we have to consider to x-axis. It is H. In dependent variable, we are getting 1 over L to the y-axis. Part 5. Label the axis and draw the rough sketch of the graph expected by you. Label the line drawn as P. X-axis H. We have to use the unit. Normally, we are measuring length by centimeters, therefore I will mark it in centimeters. Y-axis 1 over L per centimeter. Y equals mx plus C type graph. It is like this, and we have to label it as C. We have drawn with the shape. Then part 6. Write down an expression for the atmospheric pressure using the information extracted from the graph and relevant parameters. Then we can consider intercept and gradient. We have to find H value. We can write intercept divided by gradient. Intercept divided by gradient. HA over K. HA over K. We have to divide by gradient. X divide by gradient means multiply by reciprocal. Multiply by Lk over XA. Now we can cancel out A and X, A and K. then we can get the relationship HL over X. Then we can subject capital H. Capital H means atmospheric pressure. Then we can get the atmospheric pressure. Capital H equals intercept divided by gradient into x over L, x over capital L. It is the answer. If you are using directly intercept or gradient, we can't use gradient to find the atmospheric pressure. If you are using intercept, we don't know the value of K. Therefore, we can't get it by using only the intercept of the graph. We have to write by using ratio between intercept and gradient. Then it is the answer for part 6. Then part E. What is the best experimental procedure to vary H values? Underline the correct answer. Part 1, from a lower value to higher value. From a higher value to lower value. Part 2, give reason. We have to change simple H value from a lower value to higher value. E, part 1, lower to higher. Because of if we are using using H value from lower to higher, we can avoid the mercury leaving the tube. Then we can write to avoid mercury leaving the tube. Then part F. If the air trapped in the tube is not dry and contains saturated water vapor, through the experiment, sketch the expected line on the above graph and label it as Q. Now, I will consider the pressure of gas. In first situation, equals to atmospheric pressure plus pressure of mercury column. Pressure of mercury column. For the second situation, pressure of gas plus saturated vapor pressure. Saturated vapor pressure should be equal to this value. H plus P plus P mercury pressure. Atmospheric pressure plus mercury pressure. Now, when considering these two equations, we have to understand this air pressure is less than this pressure. If this one is P1, this one is P2, P2 is less than P1. Therefore, we can observe total pressure. Total pressure is a greater value for the second situation. Or we can consider in the first situation, pressure of the tube is pressure of air column. For the second situation, pressure of tube is pressure of air column plus pressure of saturated vapor. This value is a greater value. Total pressure is greater than first situation. When pressure is increasing, volume should be decreasing. Therefore, graph should be like this. It is a gas tube.